So in relation to the last video I posted, I wanted to make a short video to show a couple of popular guitar pedal schematics that utilise hard clipping diodes. I plan to do proper breakdowns of these circuits, as well as numerous others. However, for now, I'll be skipping over a lot of the components in this video, just to show the general logistics associated with the hard clipping aspects of the device. First, we'll take a look at the MXR Distortion Plus. So this distortion unit consists of a 741 op-amp that is creating the amplification within the device. The amount of amplification is determined by the resistor values utilised within the op-amp's feedback loop. With one of the resistance values being a potentiometer, the amount of gain will vary depending on the potentiometer's value. With the distortion potentiometer on the surface of the pedal at maximum, this op-amp will be creating a gain of 213. This op-amp is utilised in conjunction with the hard clipping diode configuration we took a look at last time. Before we reach the diode section, we see a resistor that limits the amount of current heading towards these diodes. There is usually a resistance value between 1 and 10k found in this location. Then we get to the diodes. The diodes in the MXL Distortion Plus are 1N34A germanium diodes, configured for symmetrical clipping. Being germanium diodes, they possess some of the characteristics we previously discussed, such as a lower forward voltage, smoother sounds, etc. One thing I failed to mention last time is germanium diodes construction lends to more fragility. Germanium diodes have glass shell exteriors that can be fragile if not handled with care. This is obviously a consideration when utilising them to construct a physical pedal design. Alongside the diodes, we also see a capacitor with a pathway to ground. This capacitor is creating a low-pass filter in conjunction with the current limiting resistor we saw before the diodes. These two components form a low-pass filter at around 15.9 kHz. This attenuates some high-end frequency content that can be unpleasant when distorted. This graph shows an approximate representation of the clipping. Next up is the Proco Rat. As you can see, there is more going on in this circuit, with the most notable difference being the tone control found here, as well as the output buffer seen here. Besides that, we have the same principles as the MXL Distortion Plus. The amplification is being provided by the LM308 op-amp, with some versions of the Rat using the OP07. Again, the resistors in the feedback loop of the op-amp are determining the gain. And even though it's in a different location, there's a potentiometer in the feedback loop utilised to adjust the amplification of the op-amp. When operating at its maximum, the amount of gain is 2305. Now if we feed 0.2 volts into the op-amp, this gain figure value doesn't mean we're going to achieve 461 volts from the output of the op-amp. The op-amp's outputted value cannot go above the value of the power it's being supplied with. It will hit VSAT, which is 2 volts below the power supply value, and this will create distortion in its own right. In some mods within pedals, you can have the choice to disconnect the clipping diodes altogether and utilise the op-amp for the clipping characteristics. But anyway, back to the clipping diodes. Again, we see a resistor that limits the amount of current heading towards these diodes. We then have the diode shunt to ground. In the Proco Rat, 1N914 silicon diodes are utilised, again in symmetrical configuration. So with the silicon diodes being utilised, there will be a higher forward voltage as well as the other qualities silicon possess. This graph shows an approximate representation of the clipping. After this stage, there is a tone control as well as further circuitry that will have repercussions on the device's sonic performance. The majority of op-amp based hard clipping circuits are configured similar to the circuits shown. So there's a look at a couple of circuits. Like I said, I will fully break down these circuits in the future as well as others. Thanks for watching.